All right, we're in section 28. And again, for some students, what this is like, they're saying, what do I need to do? Well, at minimum, probably type in this code using Sage Math. All right, the reset, which is clearing out any kind of variables that might be left over or definitions. Getting X to be a variable, defining a function F, differentiating F, solving the derivative for zero, and then plotting the function out. All right. So let me just, kind of scroll back over the notes. And I'm not trying to memorize this stuff. I'm trying to think, can I figure this stuff out? All right. So I'm kind of looking for the function x minus 3 squared, and then x squared, minus 0 square root. Wow. Looks like a distance formula problem. Now, this is related to word problems. All right. Word problems. And it looks like this one right over here. All right. It looks like this problem right over here. Now, here comes the problem. Someone says, well, do I really need to learn how to do this? Can I just go to Sage and ask Sage to solve the problem? No, you can't do that. What you need to do is realize that you need to be able to read, understand what you read, formulate a problem on paper, write down what needs to be done, and then do it. And that's what's happening when I write the Sage code at the end of this thing. The expectation is you've gone through all this work before, right? You've gone through all this work before. So let me just scroll back, and I'm looking at this one over here, x minus 1. This is 7x minus 0. Let me see if that's the same problem. And it's not the same problem. Let's keep scrolling back. Scrolling back, right? Scrolling back. It's this one. All right. It's problem right here. All right. So what I'm going to claim over here is that you might say stuff, well, I just want to avoid all the reading and the difficult stuff. And I just want someone to hand me that Sage problem that I can type in. And you know what? It would be a nice, easy career to type that stuff in. But I'll be honest with you, there are no careers like that. If you're going to head towards a STEM career, the career is going to be, can you understand what the problem is? Can you formulate the problem on a piece of paper and then solve the problem? Whether it's being solved by, hand techniques, or using a handout calculator, or using something as substantial as Sage, you got to be able to do that. All right. So I know it's a lot of work, a lot of reading, a lot of visualization, but eventually you get to something like this and you got a function over here. And what are you doing with the function? You're trying to do something with it, take its derivative. I know it looks difficult, but you do that. And I'm going to go back to the Sage code now. I'm going to type it in, and then I'll scroll back to that. All right. We'll look at it. I'm going to type it in now. Let me go my Sage. Reset. X the variable. And you'll learn. And you'll learn by typing and doing and thinking and reading and all that kind of stuff. I'm a little tired. I'm going to copy paste. 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 A lot of work there. Let me just pull this on the side. And let me get my Sage back. And I'm going to scroll back to a problem that I thought this was, right? Let's keep going backwards. I remember I thought this problem. Let's make sure you know what I thought. I thought it was this problem right here, right? And is it? Did I say f of x was equal to the square root of x minus 3 squared plus x squared minus 0 squared? Yep, I did say that. Right. The next thing, did I take the derivative of f? Yep, I did. I took the derivative of f. It's right over here. Was it work? Yeah, it was work. Was it hard work? Not really. Did I solve that derivative for the 0? Yeah, I did. And I'm going to point out, I'm not going to say it was easy to do, but I do want to point out the answers that it's given back to me. And the answer is given back to me. That's a complex number. That's a complex number. And this is a really nice, easy number. It's the number 1. All right. So I want to just scroll back over here and point out what we did. This is a cubic polynomial. This is cubic polynomial. This will have 3 solutions to it. Now, it's real coefficient. So in 119, you learn real coefficient polynomials like this. If there's complex solutions to it, they would occur in conjugate pairs. And these things are conjugates over here. Right? These 2 things are conjugate. All right. The other thing is, how did I get the 1 in my work over here? Well, we talked about it in class. And what I was using was the rational root theorem. I look for rational roots. It's the first thing I'd look for because they're the easiest ones. And I stumbled on it. And why did I stumble on it? I look for easy things. And chances are these problems are pretty easy. All right. So what else did I do throughout the problem? I found a solution to the problem. And what solution did I find to the problem? That x equals 1 was an important number, where the derivative equals 0. All right. So it's the 0.11. Right? And we want to do all that work at the board. Let me repeat this. If you're just typing this stuff in blindly, thinking this is somehow going to help you, it'll be no help at all. No help at all. All right. Now, someone says, I wonder what this is a plot of. Well, it's a plot. Right? I'm going to read the problem again to you. It's a plot of the function f. That's what this is a plot of. It's a difficult looking graph, though. And what were we trying to do with that? If you remember, we were trying to minimize it. And what does that mean? There's a point over here. You see that point? And where's that point occur at? 1. And that's an interesting concept, that we could have also graphed that out, but that's a really difficult graph to graph, and we would have gotten the minimum there over there. The problem was this: looking at this picture, I am not absolutely sure it's 1. I mean, it could be over there, a little bit less than that, but I do see the minimum in this area over here. So around 1. We showed it's 1 though. All right. Thank you.